What if I told you there's a vehicle you can drive to the mountains, press a button, and literally fly home? Not in 50 years, not in some billionaire's garage, right now, in China, being mass-produced for delivery in 2026. Yeah, I'm serious. This thing exists, it drives, it flies, and it's about to change everything you thought you knew about transportation. This is the Xpeng land aircraft carrier, and before you roll your eyes at another flying car concept that'll never happen, let me stop you right there, because this one already completed its first public crewed flight. It's got government certification, and there are over 3,000 people who've already put their money down to buy one. So buckle up, because what you're about to see is going to make Tesla's Cybertruck look like a boring old pickup truck. Let's be honest, flying cars have been the ultimate broken promise of the future for decades. Every few years, some company shows up with CGI renderings and big dreams. They talk about revolutionizing transportation, about ending traffic jams forever, about making the Jetsons a reality, and then nothing. Crickets. The hype dies. The company runs out of money, and we're all left sitting in traffic wondering what happened to our flying future. But here's why the Xpeng AeroHT land aircraft carrier is different. This isn't vaporware. It's not some garage tinkerer's fantasy. This is a fully funded subsidiary of Xpeng Motors, one of China's most successful EV makers. They've been developing flying vehicle technology since 2013. That's over a decade of testing, thousands of flight hours, and hundreds of engineers working on making this real. And instead of promising you a car that magically sprouts wings, they did something way smarter. They split the problem in half. You get a 6-wheeled electric truck that's actually useful on its own, and inside that truck, a deployable 2-seat aircraft that unfolds and flies when you need it. Think of it like this: it's not a flying car, it's an aircraft carrier for your personal flying machine. And that distinction, that's what makes this whole thing actually work. So let's break down what they've built, starting with the mothership itself. The carrier vehicle looks like someone took a Tesla Cybertruck, stretched it, added 2 extra wheels, and gave it a purpose. This thing is massive, 5.5 meters long, 2 meters wide, sitting on 3 axles with 6-wheel drive that can tackle terrain most SUVs wouldn't dare touch. The front end is sharp and angular. Cyber-mechanical is what Xpeng calls the design language, like a lunar exploration vehicle that decided to cosplay as a luxury adventure van. You've got these aggressive LED headlight strips that slice across the face, flush door handles that pop out when you approach, and instead of traditional side mirrors, cameras. Because of course, the stance is wide and planted. Those massive wheel arches house serious rubber designed for both highway cruising and off-road expeditions. And yeah, this thing can actually go off-road, 6-wheel drive with a differential lock and rear-wheel steering. It's designed to take you places a helicopter couldn't land. Walk around to the rear, and this is where it gets wild. 2 giant swing-out doors dominate the back, and behind those doors, that's where the aircraft lives, tucked away, folded up, charging from the carrier's battery while you drive. The whole vehicle screams purpose-built. This isn't trying to be pretty, it's trying to be functional. A mobile command center, a launch platform, a vehicle that says, yeah, I carry a flying machine in my trunk, what do you carry? Step inside the carrier and you're greeted with a surprisingly spacious cabin, 4 to 5 passengers depending on configuration, 2 rows of seats with legitimate legroom. The dashboard is dominated by screens, digital instrument cluster, central touchscreen for vehicle controls and flight management. Everything you'd expect from a modern EV, but with the added complexity of managing an aircraft. The steering wheel is this odd squared off design, part yoke, part traditional wheel, and throughout the cabin you've got these heavy duty grab handles at the A and B pillars, because when you're the kind of person who deploys aircraft from your truck bed, you're probably also the kind of person who takes roads less traveled. Materials are rugged but refined. This isn't trying to compete with a Mercedes S-Class in luxury, but it's way nicer than you'd expect for what's essentially a mobile aircraft hangar. Think Land Rover Defender meets SpaceX Dragon capsule. And here's the genius part of the engineering. The entire carrier runs on an 800-volt extended range electric platform. That means you've got a battery pack for pure electric driving, but also a range extender engine to keep everything charged on long trips. Total range, over 1,000 kilometers. That's over 600 miles of go-anywhere capability. But the battery isn't just for driving, it's also the charging station for the aircraft. While you're cruising down the highway, the aircraft module is docked in the back, charging up, ready for whenever you need to take to the sky. The 800-volt architecture means it can charge the aircraft from 30% to 80% in just 18 minutes. Think about that for a second. You're driving through the desert, you pull over at a scenic overlook, press a button. 4 minutes later, you're flying above the landscape while your truck waits below. That's not science fiction. That's what this thing actually does. Okay, so you've got this beast of a truck. Now let's talk about the star of the show, the aircraft itself. When it's stored, the flying module is completely compact, folded up tight in the rear cargo area like some kind of mechanical origami. Arms collapsed, rotors tucked away, landing gear retracted. It takes up about as much space as you'd normally use for luggage. But hit the deployment button and watch the magic happen. The rear doors swing open automatically. The aircraft platform slides out on rails. Then the transformation begins. 6 arms extend outward, each one unfolding like a praying mantis waking up. At the end of each arm, a rotor, 6 in total, arranged in a hexagonal pattern for maximum stability. The landing gear deploys, the cockpit canopy separates from the mothership's docking clamp, and in about 4 minutes you go from truck to functional aircraft. The engineers are working to get it down to 3 minutes, but honestly, 4 minutes to deploy a flying machine is already insane. The aircraft itself is a work of aerospace engineering art. The structure is almost entirely carbon fiber to keep weight down. Total weight of the flying module? Just 560 kilograms. That's roughly 1,200 pounds. Light enough to fly efficiently, strong enough to carry 2 passengers plus some cargo. The cockpit is this gorgeous curved polycarbonate bubble that gives you a 270-degree view. Imagine sitting in a glass sphere suspended in the sky. That's what this feels like. 2 seats side by side. The control system is deliberately simple, a single joystick for manual flight, or you can let the AI take over. Yeah, this thing has full autonomous flight capability, pre-programmed routes, automatic takeoff and landing, real-time airspace monitoring. It's basically a self-flying drone that happens to carry people. Flight performance? Top speed is around 130 kilometers per hour. That's about 80 miles per hour. Not exactly Mach 1, but remember, this isn't trying to compete with jets. It's designed for low-altitude flights, scenic tours, emergency evacuations, jumping over traffic to get to that meeting on time. Maximum altitude is 1,000 meters. That's about 3,300 feet. High enough to clear most obstacles, low enough to stay out of commercial aircraft zones. And on a full charge, you get about 25 to 35 minutes of flight time, enough for 5 to 6 short hops before you need to dock back with the carrier for a recharge. Safety systems? This is where Xpeng really flexed their engineering muscles. The aircraft has distributed electric propulsion. That's fancy aerospace speak for. If 1 or 2 rotors fail, the others can compensate and land you safely. Multiple redundant systems, obstacle avoidance sensors wrapped around the entire craft, real-time communication with ground control. And if everything goes catastrophically wrong, there's an emergency ballistic parachute that deploys automatically. This isn't some garage project with duct tape and prayers. This is certified aerospace technology. The aircraft module received its type certificate from China's Civil Aviation Administration. That's the equivalent of the FAA in the United States saying, yeah, this thing is safe to fly, and they've proven it works. In November 2024 at the Guangzhou Air Show, Xpeng's founder Zhao Deli personally flew the aircraft in front of a live audience. The full deployment sequence, the takeoff, the flight, the landing, all of it captured on video for the world to see. This thing isn't a concept. It's not smoke and mirrors. It flies, it works, and it's being prepared for mass production right now. Now you might be wondering, how did Xpeng even get here? Because this modular land aircraft carrier is actually their 2nd generation approach to flying vehicles. The first was the X2, a completely standalone flying car that looked like a teardrop shaped pod with 8 rotors. It was gorgeous, futuristic, made entirely of carbon fiber with this sleek, minimalist design that belonged in a sci-fi movie. The X2 was Xpeng's proof of concept, their way of saying, we can build something that actually flies. And they did. In October 2022, they flew it publicly in Dubai, at Skydive Dubai in front of government officials, media, and aviation authorities. It passed all the safety assessments, got its flight permit, proved the technology worked. The X2 could hit 130 kilometers per hour, fly for 35 minutes, carry 2 passengers in this beautiful enclosed cockpit that felt more like a spaceship than an aircraft. It even had both manual and autonomous flight modes. You could fly it yourself or let the computer take over. But here's what they learned. A standalone flying car is cool, but it's limited. Where do you park it when you're not flying? How do you charge it on a road trip? What happens when weather grounds you and you still need to get somewhere? So they evolved the concept. Instead of making you choose between driving and flying, they built a system that lets you do both. The carrier vehicle handles the ground transportation, long-range cruising, off-road capability, cargo space, everything a vehicle needs to be practical. And when you need to fly, deploy the aircraft, use it for the specific situation where flying makes sense, then fold it back up and keep driving. It's brilliant in its practicality, and that's why this approach has a real shot at succeeding where so many flying car concepts have failed. Let's talk about the technology that makes all of this possible, because there's some serious engineering wizardry happening under the skin of this system. First up, that 800-volt architecture. Most EVs run on 400-volt systems. Tesla. Most Chinese EVs. Even a lot of the premium European stuff, but 800 volts changes the game. Higher voltage means faster charging, more efficient power delivery, and critically, the ability to quickly recharge that aircraft module. The carrier vehicle can push power to the aircraft at rates that would normally require industrial charging infrastructure. 18 minutes from 30% to 80%. That's barely enough time to grab a coffee and stretch your legs. The battery pack in the carrier is estimated at 40 to 50 kilowatt hours. Not massive by EV standards, but remember, it's also running a range extender, a small turbocharged gasoline engine that kicks in to recharge the batteries on the fly. It's the same hybrid approach that companies like BMW use in their i3 REX or that Chevrolet used in the Volt. This gives you the best of both worlds. Electric efficiency for most driving, extended range when you need it, and the ability to operate in areas where charging infrastructure doesn't exist. The flight control system is where things get really sophisticated. The aircraft is controlled by an advanced AI that processes data from dozens of sensors in real time. Radar for obstacle detection, cameras for visual navigation, GPS for positioning, wind sensors to compensate for gusts, altitude monitoring to maintain safe flight paths. In autonomous mode, you literally just tell it where to go. The system plans the route, checks airspace restrictions, calculates battery consumption, and handles the actual flying. Takeoff is fully automated. Landing is fully automated. You're basically a passenger with a really good view, but if you want to fly manually, the joystick control is reportedly intuitive, simplified to the point where Xpeng claims you can learn the basics in a matter of hours. It's not like learning to fly a traditional helicopter or plane. It's more like flying a very large, very advanced drone. The safety systems are redundant to an almost paranoid degree. Multiple independent flight computers cross-checking each other. Distributed electric propulsion means losing one or even two rotors isn't catastrophic. The aircraft can still maintain controlled flight and land safely. And that emergency parachute system, it's designed to deploy in under 2 seconds if needed. All of this has been tested. Thousands of flight hours, hundreds of landings, multiple air shows and demonstrations. The technology isn't theoretical, it's proven. And the manufacturing infrastructure? Xpeng AeroHT is building a massive factory in Guangzhou with capacity to produce 10,000 units per year. Construction started in late 2024. First prototype off the line expected by July 2025. Mass production ramping up through 2026. This isn't a startup with a slideshow and a dream. This is a real company with real funding building a real product in a real factory. So let's address the elephant in the room. How much does it cost to own a truck that carries a personal aircraft? The answer, less than you'd think, and way more than you'd want. Xpeng has set the price at under 2 million yuan. In US dollars, that's approximately $280,000. Now, let's be clear, that's not cheap, that's expensive car territory. That's Lamborghini Huracan money, McLaren 720S money, loaded Porsche 911 turbo money. But here's the perspective flip. This isn't just a car, it's a car plus an aircraft. If you tried to buy a luxury SUV and a personal eVTOL separately, you'd be looking at way more than $280,000. A top spec Range Rover or Mercedes G-Wagon will run you $200,000 or more. And personal aircraft? Even basic kit-built helicopters start around $150,000. Professional eVTOLs from companies like Joby or Archer, not even available to consumers yet, but estimates put them north of $300,000. $300,000 when they do launch. So in a weird way, $280,000 for both is actually a bargain in that market segment. You're getting a 6-wheel off-road capable long-range vehicle plus a flying machine for less than the cost of buying them separately. The market seems to agree. As of late 2024, Xpeng reported over 3,000 intent orders. These aren't just people saying, "That's cool." These are actual buyers who've put deposits down. Companies in China buying them for executive transport, adventure tourism operators, search and rescue organizations, even some governments looking at emergency response applications. And it's not just staying in China. The Middle East has shown massive interest. The UAE has signed strategic partnerships to test and certify the system for their airspace. Orders from Dubai, from Saudi Arabia, from adventure destinations where flying over terrain makes way more sense than trying to drive through it. Deliveries are scheduled to begin in late 2026 in China, international expansion to follow. Europe and the Middle East are likely to see it before the United States due to regulatory differences. The FAA is notoriously slow to certify new aircraft categories. But eventually, this is coming to a world near you. Okay, but let's get real for a minute. Will this actually work at scale? Or is this just another expensive toy that'll flop the moment it hits the real world? Fair questions. And honestly, it depends on what you mean by work. If you're asking whether the technology functions, the answer is yes. We've seen it fly, we know it works. The certifications are real, the engineering is sound. If you're asking whether regular people will use this for daily commutes, the answer is probably no. At least not in the near future. You can't just fly wherever you want. Airspace is regulated. You need permits, flight plans, clearance. Even in China's more relaxed low-altitude economy, you can't just launch your flying machine from your driveway and buzz over to the grocery store. But that's not really who this is for. This is for the adventurer who wants to explore remote areas, the executive who needs to bypass traffic to get to multiple sites in a day, the emergency responder who needs rapid deployment capability, the resort operator who wants to offer guests an unforgettable experience. It's for people who have legitimate use cases where flying actually solves a real problem, and there are more of those people than you'd think. The regulatory challenges are real. The United States and Europe have very strict aviation rules. The land aircraft carrier would need completely separate certifications from the FAA and EASA. That could take years, and even then, where you can fly would be heavily restricted. But China is going all in on what they call the low-altitude economy. They're building out dedicated aerial corridors, simplified certification for personal aircraft, infrastructure for charging and maintenance. They're betting that urban air mobility is going to be a massive industry in the next decade, and they want Chinese companies leading the way. So will every American have one in their garage by 2030? No. Will this become a viable transportation option for specific use cases? Almost certainly yes. Will it push the entire aerospace industry to think differently about personal aviation? Already happening. Here's the question that really matters. Would you actually trust this? Would you put your life in a flying machine built by a Chinese EV company? Because let's be honest, there's a perception issue here. When people think aerospace, they think Boeing, Airbus, Cessna, Gulfstream, legacy American and European companies with decades of aviation experience. They don't think Xpeng, a company that's been making electric cars for less than 10 years and flying vehicles for even less. But here's the thing, aviation is increasingly becoming an electrical engineering problem, not a mechanical engineering problem. And who's really good at electrical engineering? Who's been leading the world in battery technology, electric motors, and software integration? Yeah, Chinese EV companies. Tesla proved that you don't need to be a 100-year-old automaker to build compelling electric vehicles. Xpeng, BYD, NIO, they all took that lesson and ran with it, and now they're applying the same logic to aviation. Plus, let's not forget that Xpeng AeroHT has been at this since 2013. That's over a decade of research and development, thousands of test flights, government certifications, real engineering pedigree. Are there risks? Sure, any new technology has risks, but the same engineers who designed this also designed the Xpeng P7 sedan, which has some of the most advanced autonomous driving tech in the world. The same company that built this also builds EVs that are widely considered to be among the most innovative in the industry. The future of aviation isn't going to come from companies trying to incrementally improve century-old designs. It's going to come from companies willing to completely rethink what's possible. And right now, Xpeng is showing the world what that looks like. So here we are, a 6-wheeled electric truck that carries a deployable flying machine, built by a Chinese company, certified by aviation authorities, being manufactured at scale, with thousands of pre-orders, scheduled for delivery in 2026. This isn't a concept, this isn't vaporware, this isn't some billionaire's garage project. This is real, this is happening, and it's going to force every traditional automaker and aerospace company to ask themselves a very uncomfortable question. If a Chinese EV startup can build a flying car that actually works, what the hell have we been doing for the last 50 years? The age of flying cars isn't coming, it's already here. It just showed up from a direction nobody was watching. Would you drive one? Would you fly one? Or does the whole idea still feel like science fiction that isn't quite ready for the real world? Drop your thoughts in the comments. And if you want to see more insane vehicles that are actually being built right now, smash that subscribe button, because the future is happening faster than anyone expected. And I'll be here to show you every wild second of it. See you in the next one.